Hello and welcome back to Maths Made Easy. Today we are going to start second exercise in chapter 7 of class 12. Detailed solution with explanation. In this lecture we are going to cover question number 1 to 10. Further we are going to solve in other lecture. By the way, here are some basic result in integration which you can take the screenshot if you want. There is a quick tip. When the result is starting with C, with that I mean cos, cot and cosec, the result is always negative. Many of them might not know about this. Sin, the result is cos. Similarly, cosec is minus cot. Anywhere, when you see there is a result starting with cos, cot, cosec, it's always negative. So just keep in mind, this is going to be very helpful if somebody forget about the signs. Okay, exercise 7.2, integrate the function in exercise 1 to 37. The question is 2x divided by 1 upon x square. Okay, the second exercise of chapter number 7 is totally based on the idea of substitution. We are going to substitute any of the values to make our question look simpler. So in this case, if you see, we have 1 plus x square, and we know that the 1 plus x square, whenever you find derivative of this, you will get 2x, because the derivative is always nx raised to n minus 1. So in this case, I am going to substitute 1 plus x square as t. Let 1 plus x square is equal to t. Therefore, I have d upon dx of 1 plus x square is equal to d upon dx of t. Therefore, I can write derivative of 1 is 0 and x square is 2x is equal to dt upon dx. So basically, I can say that 2x dx is equal to dt. Whenever we substitute anything to t or any other variable, we are always going to reach this situation. We have to get our numerator with dx to be replaced with something different in other variable. So our question is like this: 2x, I'm sorry, let me cut this one, 2x dx divided by 1 plus x square. So you know that 2x dx can be replaced with dt, and x plus 1 plus x square is t, as we have already assumed here. So this is equal to dt upon t. Now, if you remember the previous slide, the formula 1 upon x is always log x. When we integrate 1 upon x, we get log x. So here we can write log of t plus c. But don't forget to resubstitute the value of t. So our final answer is log of 1 plus x square plus c. I hope you got this question. Let's move on to the next one. Log x the whole square upon x. Okay, what you will substitute in this case? We all know the derivative of log x is 1 upon x. So our question is like this: log of x the whole square divided by x dx. If I substitute log x as t, I will get 1 upon x dx is equal to t. Let me show you how. Let log x is equal to t. Therefore, I can write d upon dx of log x is equal to t. I can also write 1 upon x. 1 upon x is equal to dt upon dx. That gives me dx upon x is equal to dt. I'm going to substitute this over here. So I got dx upon x is equal to dt. In our case, dx upon x will be replaced by dt. So we have here t square dt. Now, x raised to n, integration of x raised to n, you all know this. T raised to 2 plus 1 upon 2 plus 1, that is t raised to 3 upon 3 plus c. Don't forget to resubstitute the value of t. So we have here log of x the whole cube divided by 3 plus c. I hope you got this question. Let's move to the next one. 1 upon x plus x log x. Okay, how will we handle this question? Let's take this x common first of all, because we all know that log x is 1 upon x. When we do the derivative of log x, we get 1 upon x. So when we take x common out of the bracket, you will see this question as like this: dx upon x 1 plus log of x. So in this case, if I take 1 plus log x as t, let 1 plus log of x is equal to t. So I can write d upon dx of 1 plus log x is equal to d upon dx of t. Derivative of 1 is equal to 0. So it is equal to 1 upon x is equal to dt upon dx. Finally, the value of dt is equal to dx upon x. So in this case, dx upon x will replace by dt, and 1 plus x we have already took as t. So what I have here is dt upon t. Now you know that it's like the first question. It is equal to log of t plus c, and don't forget to resubstitute the value of t, which is equal to log of 1 plus log of x plus c. I hope you got this question. We will be moving to the next one now. Sine of sine cos x. Okay, what will you do for this one? This looks like a complex. It's not only sine x or not only cos x or not only sine of ax plus b. This is something really little complex, or else you cannot think of what to do. In this case, we are going to substitute this cos x as t, because the derivative of cos x is equal to minus sine x, and we have sine x here. We can play around it. Okay, let's see. Our question is like this: sine x into sine of cos x dx. Let cos x is equal to t. So the derivative of cos x is equal to, I will do like this, d upon dx of sorry for this handwriting, d upon dx of cos x is equal to d upon dx of t. Now, derivative of cos x is minus sine x. Minus sine x is equal to dt upon dx. But we are only interested in sine x dx. See, I want to replace this sine x and dx with dt. So I'm going to take this negative sign on the other side. So we have dt dt is equal to minus sine x dx. So our question will look like this: sine t dt with negative sign. integration of cos t is, integration of sin t is cos t. Since the result is cos or something with c, you can put negative sign there directly. Minus cos t plus c. This minus and this minus will become positive. So we have cos of t plus c. Don't forget to resubstitute the value of t, which is equal to cos of cos x plus c. I hope you got this question. Now let's move to the next one. Question number 5. Sin ax plus b cos ax plus b. Now this looks a little tricky one because it is not direct substitution. We are going to adjust this question so this become very simple for us. Let's start. Sin ax plus b cos ax plus b. What I did here, I multiplied my equation with 2 and divide with 2. Now this looks like a formula of sin a cos a, which is equal to sin 2a, 2 sin a cos a. So what I can write over here is integration of sin ax plus b cos of ax plus b can be written as 1 upon 2 outside the integration, this 1 by 2, and this 2 sin ax plus b cos ax plus b I can write in this form. So I have here sin of 2 times ax plus b. Sin of 2 times of ax plus b, because sin a cos a, 2 times of sin a cos a can be written as sin 2a. Taking this 1 upon 2 out of integral, we have to integrate cos 2 ax plus b. Now integration of cos, I'm sorry, I'm always confusing between cos and sin. Please for sin 2 ax plus b. Integration of sin 2 is cos 2, right? With negative sign. So what I will be doing here, minus cos of 2 ax plus b, and further I will divide my integral with the function, with the other function, that is, because here we have integral function, trigonometric function and algebraic function. Whenever I will be doing integration of the main function and dividing it with the other function. Other function is algebraic function. We are going to do division by derivative of the algebraic function, d upon dx of 2ax plus b. In here I will get only 2a because x will go by itself because it is x minus 1, x raised to 1 minus 1, and b is a constant, so it is also 0. 1 upon minus 4a cos 2 ax plus b is my answer. You might have noticed we haven't substituted anything here. We did not substitute. So that's why we don't have to resubstitute anything. Just we had did some adjustment in here. So the equation becomes simpler because this is already sin a cos b. If you go into the formula of u into v, which we are going to look in future, that may solve our question, but it will take a long time. It will take a lots of steps, and you don't have too much time to waste on if you have a simple option available. Okay, under root of ax plus b. This is very simple, and I'm not going to attend the entire. What you can do is here ax plus b power 1 by 2. Okay, now apply the formula of x raised to n, which is x raised to n plus 1 upon n plus 1. But the only one thing you have to keep in mind is this has a radical sign on top of it, which is exponent, that is 1 by 2. We will be writing integration for the exponential term, exponential function, and then we will be dividing it with, okay, let me solve it. So in this case, our answer is integration of ax plus b raised to 1 by 2, which can be written as ax plus b power 1 by 2 plus 1, 1 by 2 plus 1, and then whole divide by derivative of ax plus b plus c. Ax plus b, it is going to give me only a. So I will just conclude it very fast. Ax plus b power 3 by 2 a, which can be written as 2 times 2 by 3 ax plus b power 3 by 2 divided by a plus c. I hope you got this question. We'll move to the next one. X root of x plus 2. Now here is something that you cannot do it by putting power 1 by 2. So let's substitute this with a under root of x plus 2. I will take x plus 2 as t. So I got the value of x, that is t minus 2. And at the same time, when you do derivative, you will find dx is equivalent to dt. So in this case, our integration looks like in x root of x plus 2 dx. So in place of x, what I will put here is t minus 2, and in place of x plus 2, I will be putting x plus 2 is equal to t. So t raised to 1 by 2, since it was a root. Now dt will be replaced by dx will be replaced by dt. So our equation looks like this one. You will be taking this 1 upon 2 inside the bracket. So this t raised to 3 by 2 minus 2 times of t raised to 1 by 2 dt. Now please use the formula x raised to n plus 1 upon n plus 1 to further simplify this question and substitute the value of t later and to x plus 2. X 1 plus 2 x square. Similar question, we are going to take inside term as t. So we have t outside, and we will be trying to replace this x either by solving for derivative or by direct substitution. Like in this case, we substitute the value of x directly. We did not make any derivative, because in case we go for derivative, the value of x will become 1 and 0, and we cannot replace x. But in this case, the value of the power of x is x square. When we take derivative, the power is reduced by 1, and in that case, we may be able to find the substitution for this one. So we will be trying that one. Let 1 plus 2x square is equal to t. So our answer, our derivative is 4x dx is equal to dt. But we are only interested in x dx. So I will be sending this 4 to the other hand. So x dx is dt upon 4. And then it's simple. X root of 1 plus 2x square dx. So it is equal to 1 upon 4 root of t dt, because x dx was equal to dt upon 4, dt upon 4. So x dx, I write 1 upon 4 and dt, and then inside the root we have t. This is just simple steps which you already know about it. And then we are going to substitute the value of t. Okay, 4x plus 2 root of x square plus x plus 1. In this case also, we are not going to directly substitute the value of x. First we will be finding derivative, and then we will try to replace x, because outside the bracket, see the difference in the last 3 questions. The value of x inside the root, I will show you here. These are some indication. The power of x is same inside the root and outside of the root. So you can directly substitute. And in this case, in these 2 cases, the power of x was different. So in here also, if the power of x is 2 and the outside is 1, we go for derivative, because when we go for derivative, the power is already reduced by 1, and then it is very easy to substitute. So I have done the initial steps. From here you have to carry on. This is root of t, so you will be writing it as root of 1 up t raised to 1 by 2, which when formula is applied, it becomes t raised to 3 by 2 divided by 3 by 2, and then resubstituting the value of t, that is x square plus x plus 1. Question number 10, 1 upon x minus root of x. Okay, this one I will be solving. We are going to take root x common here, because x can be written as root x times root x. So very first step, we are going to take root x common. Okay. Now, when we take this one as t, you know the derivative of root x is 1 upon 2 root x. Keep in mind, when derivative of root x is always 1 upon 2 root x. So we are going to take root x minus 1 as t. 1 upon 2 root x dx is equal to dt. But we are only interested in root x. 1 upon root x, dx upon root x. So this 2 will be shifted to other hand. So this becomes 2 dt. Instead of dx upon root x, I will be writing 2 dt, and then the question is solved. So this is our question. We took root x common, and then it can be written as 2 dt upon t. I will be taking 2 out of integral sign, and then we have dt upon t, which you can write log of t. Integral of 1 upon t is log of t plus c. So log of t plus c, resubstituting the value of t, that is root x minus 1 plus c. So I hope you like this video. If you did, then please subscribe to my YouTube channel, and I will see you in the next one. Thank you very much.
Hello and welcome back to Maths Made Easy. Today we are going to solve question number 31 to 39 from chapter 7 of class 12 integral. These are some basic formula that you can take screenshot if you need. Okay, question number 31. Sin x upon 1 plus cos x the whole square. Okay, we are going to substitute 1 plus cos x as t. Since the derivative of 1 is 0 and the derivative of cos x is minus sin, so we will make some adjustment to remove this sin x dx. Like here, if I substitute 1 plus cos x is equal to 2, I can say that sin x dx can be replaced with minus dt. So I'm going to write the same thing again. Integral of sin x upon 1 plus cos x dx is equal to, can be written as minus of integral dt upon t square, since it is 1 plus cos x the whole square. So finally, we have 1 upon t square here. So we know that actually it's a ready-made formula, 1 upon x square dx is equal to minus 1 upon x. Just a quick reference result you can always use. So 1 upon t square can be written as, the integral of 1 upon t square is minus 1 upon t. But we already have one negative sign here. So these two negative sign will give us positive. So we get 1 upon t plus c. But don't forget to resubstitute the value of t. So we have I is equal to 1 upon 1 plus cos x plus c. Let's move to the next one. 1 upon 1 plus cot x. We can write cot x as cos upon sin x. Later cross multiplication, sin x plus cos x upon sin x, and by taking the reciprocal we have sin x upon cos x plus cos x. Sin x upon sin x plus cos x. So we can write integral of 1 upon 1 plus cot x dx can be written as integral of sin x upon sin x plus cos x dx. Now, we have to make some adjustment so that if I substitute this part as t, I must be getting the derivative of this in my numerator. But before we do that, always make sure that you are not changing the equation. You will be manipulating it, you will be doing some adjustment, but you don't have to. Overall, the value of equation should be same. So I'm going to divide and multiply by 2, 1 by 1. Okay, now we have sin x, meaning to say that I have 2 sin x plus sin x. I just need cos x 2 times. So I will be writing plus cos x minus cos x. Like here, plus cos x minus cos x. Later on, 2 sin x can be written as sin x plus sin x. So what my plan is, I will be taking this sin x cos x, this sin x cos x, one term, and all cancelled. This sin x minus cos x upon sin x plus cos x, another term. We'll see how we can do that. Okay, here it is. Sin x plus cos x, sin x plus cos x cancelled each other, and we have dx. Sin x minus cos x, sin x plus cos x. Now you will be seeing that if I take this as t, sin x, the derivative of sin x is cos x available here. In another sign, derivative of cos x is sin x. Let me write here d upon dx of sin x plus cos of x. Derivative of sin x is always cos x, and for cos it is minus sin x. If I take minus sign common, I can write here as sin x minus cos of x. So what I am intending to do is, I will be substituting this as t, and this whole term will be replaced with minus dt like we did in the first question. So minus dt, it was 1 upon t, negative sign outside, 1 upon t can be written as log of t. So minus log of t, that later we resubstitute the value of t, that is sin x plus cos x plus c. An integral of 1 is x. Well, I'm gonna take this question up to the next question. So from there you can continue. The previous question was 1 upon 1 plus cot x, and this is 1 upon 1 plus tan x. So my intention is to take you till there, and then you will be continuing it by yourself. Let us write 1 upon 1 minus sin x upon cos of x. Cross multiply will give us cos of x upon cos of x minus sin x. Okay. Of course, there is dx here. Now divide and multiply by 2 like previous question. 2 of cos x upon cos of x minus sin of x. Later you need sin x, you need minus sin x plus sin x. 1 upon 2 cos of x minus sin x, cos of x minus sin x dx plus 1 upon 2 cos of x plus sin x, cos of x minus sin x dx. This is cancelled. 1 upon 2 integration of 1 is x plus, can you see the derivative of denominator in numerator? Cos x. The derivative of cos x is minus sin x. So our answer will be like this something. Let me write here. Minus 1 upon 2 log of cos x. I already solved the question. I didn't intended to solve this, but it's okay with the flow. Plus c. Later on this plus and minus sign will become minus 1 upon 2 x minus 1 upon 2 log of cos x minus sin x plus c. Let's move to the next one. Root of tan x upon sin x cos x. Okay, very interesting question. Here we are going to see how we can manipulate the equation to get our desired result. Okay, first I will be dividing the denominator with cos x and multiplying with cos x, of course. So sine upon cos will become tan x. In numerator we have tan x, and in denominator also we have tan x, but this was root and this, so they will be cancelled. Let's see, let's start. Okay, as I said, cos x, I will be dividing with cos x and multiplying with cos x. Later this cos x and cos x will become cos square x. Like you see here, tan x times cos square x. This root tan x and tan x will cancel, and we get root of tan x in denominator. And 1 upon cos square x will become sec square x. Sec square x upon root of tan x. Now, now tan x can be written, we can take tan x as t. So the derivative of tan x is available in the numerator, that is sec square x. Let tan x is equal to t, derivative of tan x, that is sec square x dx, is equal to dt. So this part will be replaced with dt, and this will be t, 1 upon root t. Finally, we have integration of 1 upon root t, which again we have a ready-made result. You can always use integral of 1 upon root x is equal to 2 root x. So this is 2 root of t plus c. Later, resubstituting the value of t, that is tan x, 2 root of tan x plus c is our answer. Let's move to the next one. Okay, 1 plus log x the whole square upon x. In this question, you will be substituting 1 plus log x as t. Let us write here 1 plus log of x is equal to t. Later, d upon dx of 1 plus log of x is equal to d upon dx of t. 1 plus log x, derivative of 1 is 0 and log x is 1 upon x, is equal to dt upon dx. You can send this dx here. So we have dx upon x, that is equal to dt. Meaning to say that this x and here there is dx. This will be replaced with dt. And we have 1 plus x, that is t. So we have t square dt can be written as t cube upon 3 plus c. Later you will be resubstituting the value of t, that is 1 plus log of x the whole cube upon 3 plus c. Let's move to the next one. Again, I'm going to do it half. Later you have to continue. X plus log x. We will be taking x plus log of x is equal to t. Let us do the derivative of d upon dx of x plus log of x is equal to d upon dx of t. Derivative of x, that is 1 plus 1 upon x dx is equal to dt. It can be written as x plus 1 upon x. Now you can see that x plus 1 upon x dx, x plus 1 upon x dx will be replaced with dt, and we have here t square. So this is t square dt, t cube upon 3 plus c is equal to x plus log of x the whole cube divided by 3 plus c. Let's move to the next one. X cube sine of tan inverse x raised to 4 upon 1 plus x raised to 8. Okay, how we can solve this one? First we will be substituting this part, and then later we will be substituting this entire part, and then the question is done. Let's see how. Let us x raised to power 4 be m. So the derivative of x raised to power 4 is equal to 4x cube dx is equal to dm, since we are substituting with m. So we have x cube is equal to 1 by 4 dm. X cube is equal to x cube dx is equal to 1 by 4 dm. Later on, I am going to substitute tan inverse m as some other variable. Let it be t. Tan inverse m as t. So we have dm upon 1 plus m square is equal to 2 is equal to t. Since we all know that derivative of tan inverse x is equal to 1 upon 1 plus x square. Since we have, no, here it is m. Please forgive me. 1 upon 1 plus m square is equal to dt. And how we got here m square? Since there is x raised to 8. X raised to 4 is equal to m. So this is going to be x raised to m raised to 2. Finally, we have 1 upon 4 out of integral sin t dt. Integration of sin t is cos t with negative sign minus cos t. We have minus cos t. Resubstitute the value of t. Later resubstitute the value of m, that is x raised to 4. So finally we got our answer as minus cos tan inverse x raised to power 4 upon 4 plus c. Let's move to the next one. Oh, very easy one. You have to take this as t. Since the derivative of this is available here, I know in your textbook there is options. So you can already tackle it with this. Derivative of x raised to 10 is 10x raised to 9. We already have. And the derivative of 10 raised to x is 10 raised to x log of x. Both are available in the numerator. So our answer is log of x raised to 10 plus 10 raised to x plus c. Let us solve it. I am going to take this part as t. D upon dx of x raised to 10 plus 10 raised to x is equal to d upon dx t. So this entire part will be replaced with dt. Finally, 1 upon t, we have integral of 1 upon t as log of t plus c. Resubstitute the values of t. That's it. Again, very interesting. Sin square x plus cos square x. You have to think a next level out of box. Let's substitute the value of 1, that is sin square x plus cos square x. Okay. By the trigonometric identity, we can write sin square x plus cos square x instead of 1. And then we will be separating the terms. Sin square cancelled, cos square cancelled. 1 upon cos can be written as sec square x, and 1 upon sin can be written as cosec square x. Integration of sec square x is 10x and cosec square x is minus cot x. That's it. Cot x plus c. Here we complete our exercise number 7.2. In our next videos, I am going to start exercise number 7.3 and let's see how many parts we are going to do it. And I hope you got value from this video. If you did, then please subscribe to my YouTube channel. We'll see you in the next one. Thank you very much. Welcome to Maths Made Easy. Today we are going to solve question number 11 to 20 of exercise number 7.2, chapter 7, class 12, that is integral. So let's start. By the way, these are some basic results that you may need in your problem solving. So please take screenshot of this. Question number 11. X upon under root of x plus 4, where x is greater than 0. So in this question, we are going to substitute x plus 4 as t. X plus 4 is equal to t. Therefore, we get the value of x as t minus 4. This x will be replaced by t minus 4 and x plus 4 will be replaced by t. At the same time, the value of dx is equal to dt by taking derivative of this term. So we have dx is equal to dt. Now let's put in the values. I is equal to integral of t minus 4 root of t dt. This can be written as t minus 4 times t to the power minus 1 upon 2. Since this root t we can write root t as t raised to 1 by 2, and from denominator it's shifting to the numerator. That's why we can write t minus 4 times t to the power minus 1 upon 2. Now this t will go inside the bracket. Let's see what happened with that. So t minus 4, t times t to the power 1 upon 2, that is t 1 times t minus 1 upon 2. By law of indices, this becomes t 1 upon 2, and similarly with 4 there is nothing, so we can write t to the power minus 1 upon 2. Hence we have this. By applying integral, we can write t to the power 1 upon 2 plus 1 whole divided by 1 upon 2 plus 1. T to the power minus 1 upon 2 plus 1 whole divided by minus 1 upon 2 plus 1. Since integral of x raised to n can be written as x raised to n plus 1 whole divided by n plus 1 plus c. By using this law, I can write this. Now just a basic simplification and you will reach here. I is equal to 2 times of t to the power 3 by 2 divided by 3 minus 8 times root of t plus c. Don't forget to resubstitute the value of t that we have already assumed here, that is x plus 4. Hence, this is our solution. Let's move on to the next one. By the way, if you can remember, try to remember this. Integral of 1 upon root 2 is equal to 2 root x. I'm sorry, integral of 1 upon root x dx is equal to 2 root x. Question number 12. This is very important. Pay attention to this. X cube minus 1 to the power 1 upon 3 x raised to 5. If you take this as t, how will you get the value of x to the power 5? Well, we have a solution for that. This x to the power 5 can be written as x to the power 3 and x to the power 2. If we take x to the power 3 minus 1 as t, so we got already the value of x to the power 3, that is t minus t plus 1. This will replace our first term. X square will be replaced if we take derivative of this, because now it is 3x square is equal to dt upon dx. So x square can be replaced by written as dt upon dx 3, or x square dx can be written as dt upon 3. So let's do this. Okay, let us substitute x cube minus 1 as I told you before. Now taking the derivative of this, this x to the power 5 can be written as x cube plus x cube times x square. I have already substituted the value of t, x square dx and the value of x cube. Now I will be taking 1 upon 3 common out of the bracket, and then this out of the integral then t to the power 1 by 3 will go inside the bracket. Let's see what happened with that. Here, same. I am taking 1 upon 3 out of the integral, and 1 upon 3 t to the power 1 by 3 is going inside the bracket. So we have 4 by 3, we have 1 by 3 inside the bracket. You can say this. Now just a basic formula of integral, that is x to the power n, can be written as x to the power n plus 1 upon n plus 1 plus c. So you have, and don't forget to resubstitute the value of t. Let's move to the next one. X square upon 2 plus 3x cube to the power 3. Let us substitute this term as t. So we have, in denominator we have t cube. And how about x square? This will be diminished when we take derivative of this t. Okay, already substituted derivative, and x square dx can be written as dt upon 9. Okay, let me substitute it. So our integral x square upon 2 plus 3x cube to the power 3 dx can be written as 1 upon 9 integral of 1 upon t cube dt. Now we all know 1 upon anything, this will shift to the numerator with t raised to minus 3. Now applying the basic integral formula, n plus 1 upon n plus 1, we have t to the power minus 2 upon minus 2. Now resubstitute the values of t. 9 times 2 is 18, and this minus sign here, minus 1 upon 18 times 1 upon t square plus c, but the value of t is 2 plus 3x cube. So this is our final answer. Let's move on to the next one. 14. Question number 14. 1 upon x log x to the power m, where x is greater than 0 as well as m is not equal to 1. I am substituting log x as t. Since the derivative of log x is 1 upon x, so my x 1 upon x and dx will be used for dt. Integral 1 upon x log x m dx can be written as integral of dt upon t raised to m. Further, this t will go on in numerator, t to the power minus m. Now using the basic integral formula, m minus m plus 1 minus m plus 1, but don't forget to substitute the value of t. Okay, what is happening here? It's nothing, it's just arranging for the better visual. Since minus m plus 1 can be written as 1 minus m. That's it. Let's move on to the next one. X upon 9 minus 4x square. Same. I want to leave this for you all, but I will solve it very quickly. Let's take this as t. So when you make derivative of this, you will get minus 8x. So this x and dx is already sorted. Let's see how. I is equal to minus 1 upon 8 integral of 1 upon t dt. 1 upon t integral of 1 upon x is log x. So 1 upon t can be written as log of t. Later we will substitute the value of t. That is it. E to the power 2x plus 3. Well, you can take this as t or anything, but I would like to solve it very easy way. The basic concept of integration. What it says, integrate and divide it with the derivative of the function. If the function is composite function, this is composite of exponential function and algebraic function. So first of all, you should be knowing that integral of e raised to x is what? Integral of e raised to x is e raised to x divided by derivative of x. And the derivative of x is 1. That's why always it is not visible, but it is there. So in this case, I'm going to integrate e to the power 2x plus 3 dx as e to the power 2x plus 3 and d upon dx of 2x plus 3. You will see. Here. Now derivative of this term is 2. That is it. This was very easy. You could have also done it in this way, the complicated way, that is let 2x plus 3 is equal to t. Now d upon dx. Anyways, you are doing here also. D upon dx of 2x plus 3 is equal to d upon dx of t. And then this is 2 dt upon dx. You substitute this here. I don't, if you can do it in simple way, don't go complicated. Question number 7. X upon e raised to x to the power 2. Okay, let's take this x to the power 2 as t. Since the derivative of this is available in numerator, always remember, if we are for the substitution, this comes with a practice, but it is always helpful to know the trick. The expression whose derivative is easily available, we are going to substitute that as t or m or whichever variable you are comfortable. So derivative of 2x is a derivative of x square is 2x. Since x is available in the numerator, with 2 I can play around. I can, if there is no, I can add. If there is extra, I can send it to LHS, RHS, anywhere to get my question done. Okay, I hope this is clear. 1 upon 2 integral of 1 upon e raised to t dt. It can be written as e raised to minus t. Now applying a simple e raised to t can be written as e raised to minus t. Now when you go for integration of this, what you do, like last time, e raised to x is equal to, integral of e raised to x is e raised to x upon dx of x. So this becomes 1. So basically e raised to x upon 1. In here, e raised to minus t upon d upon dt of minus t. This is minus 1 here. But don't forget to resubstitute the value of x. I mean the value of t. The value of t is x square. So I am going to substitute here. Instead of minus t, I will get x square. Okay. Question number 18. E to the power tan inverse x upon 1 plus x square. Now, see whose derivative is available. If you remember your derivative classes, derivative of tan inverse x is 1 upon 1 plus x square. So in this case, I am going to take this as t. Since its derivative is easily available, the question is you should be remembering those derivative. So let's substitute tan inverse x is equal to t. Derivative of tan inverse x is equal to dt upon dx. This, when you write derivative, you will get 1 upon x minus x plus x square dx is equal to dt. Now this part here is dx, can be replaced with dt, and this is t. You will see how simple it is. This was our expression, and later it can be written as e raised to t dt. Now you know the integration of e raised to x or e raised to t with respect to t. It is nothing but e raised to t plus c. Later substitute the value of t, e raised to tan inverse x plus c. Question number 19. A very tricky question. E raised to 2x minus 1 upon e raised to 2x plus 1. Can you find derivative of numerator and denominator, or the derivative of denominator in numerator? There is no available. We are going to adjust dividing numerator and denominator with e raised to x. If I divide here e raised to x, 1 upon e raised to x can be written as e raised to minus x. So finally we reach here. Now I think you can see the derivative of this term is available here. E raised to x plus e raised to minus x. Derivative of e raised to x plus e raised to minus x can be written as e raised to x plus e raised to minus x upon minus 1. It is e raised to x minus e raised to minus x. So I am going to take this term as t, and this term will go with dx to make dt. Clear? Let's substitute e raised to x plus e raised to minus x is equal to t. So we have reached to our integral of dt upon t. This can be written as log of t. We all know 1 upon x, the derivative of integration of 1 upon x is log x. So 1 upon t with respect to t is log t plus c. Don't forget to resubstitute the value of t. E raised to x plus e raised to minus x plus c. Finish. Let's move on to the last one. A similar kind of question. You can see the derivative is available for this one. Since this e raised to 2x plus e raised to minus 2x can be written as, when you write d upon dx of this, e raised to 2x whole divided by derivative of 2x, that is 2, plus e raised to minus 2x whole divided by derivative of 2x, that is minus 2x. Later we can take this 1 upon 2 common, and here e raised to 2x minus e raised to minus 2x dx is equal to dt upon 2. So I is equal to 1 upon 2 integral of 1 upon t dt. Again 1 upon t is log of t. Don't forget to resubstitute the value of t. Hence we got our answer. I hope you like this video. If you did, then please subscribe to my YouTube channel. I will see you in the next one. Thank you very much. Hello and welcome back to Maths Made Easy. Today we are going to solve question number 21 to 30 from exercise 7.2, chapter 7, class 12, integral. Detailed solution with example, with explanation. These are some basic results in integration. If you need, please take screenshot of this. We may use this. Question number 21, tan square 2x plus 3. Okay. We don't need to substitute anything here since it is very simple. I will show you how. Integral of tan square 2x plus 3 dx. We are going to integrate this trigonometric function and then divide with the derivative of the other function, whatever may be the function. In this case, this is algebraic function. So, but before that, we have to make sure that tan square, we have the integration of tan square. Since we do not have, we will be converting it into sec using the formula of identity. So tan square x can be written as sec square x minus 1. Now we will be integrating it. Integration of sec square x dx minus integration of dx. Since there is minus 1, so I will write here my nothing instead of minus 1. Now integration of sec x, you know it is tan x. So I am going to write here tan x whole divided by derivative of x, that is the function. In this case our function is 2x plus 3. Integration of 1 is x, since there is minus, so it's minus x. Derivative of 2x plus 3 is 2. Finally we got our integration, that is tan 2x plus 3 upon 2 minus x plus c. Let's move to the next one. Sec square 7 minus 4x. Same as before. This is already sec square. We know the integration of sec square is 10x. So let's apply. 10x whole divided by derivative of x. That is the function. Any function it could be. We have to get the derivative of that function. This is algebraic function. So I will write d upon dx of 7 minus 4x. Finally it is minus 4. That's it. Sine inverse x divide by root of 1 minus x square. Let us take sine inverse x as t. Why? Since the derivative of sine inverse x is available here, d upon dx of sine inverse x dx, dt upon dx, derivative of sine inverse x is 1 upon root of 1 minus x square. This dx will come here in the numerator. So we have dx upon root of 1 minus x square as dt. So in this part is going to be our dt, and this is t as we have assumed or substituted there. So I is equal to integral of sine inverse x upon root of 1 minus x square dx can be written as t times of dt. Now you all know what is integration of x, that is x to the power 1 plus 1 upon 1 plus 1, 2. Same. T square upon 2 plus c. Don't forget to resubstitute the value of t. That is sine inverse x. I is equal to sine inverse x to the power 2 upon 2 plus c. Easy. Let's move to the next one. Question number 24. 2 cos x minus 3 sin x whole divided by 6 cos x plus 4 sin x. What I can do here is I can take 2 common from this part. So I will be having 3 cos of x plus 2 sin of x. And now the derivative of this part is available in the question. Derivative of cos x is minus sin x, and derivative of sin x is cos x. Derivative of cos x is minus sin x, and derivative of 2 sin x is 2 cos x. You will see how. I took 2 common. 3 cos x plus 2 sin x is equal to t. D upon dx of 3 cos x plus 2 sin x is equal to dt upon dx. Minus 3 sin x plus 2 cos x dx is equal to dt. Now you can compare it with our question that we have 2 cos x, okay, there. Do we have minus 3 sin x? Yes, we have. So this whole part is t, I mean dt. And this part is t as per our substitution. So we have 1 upon 2 integral of dt upon t. We all know that 1 upon x is log x. When we want to find the integral of 1 upon x, it's log x. So similarly 1 upon t is equal to log of t with respect to t. Don't forget to resubstitute the value of t. One upon 2 log of 3 cos x plus 2 sin x plus c. 25. 1 upon cos square x 1 minus tan square x. Okay, what we can do here is 1 upon cos square x can be written as sec square x. Sec will go up, and we all know that derivative of tan x is sec square x. So this is going to help us. I'm going to take 1 minus tan x as t. 1 minus tan x is equal to t. Derivative of 1 minus tan x is equal to dt upon dx. Derivative of 1 is 0 and minus is as it is 10 is sec square x. So I have sec square x dx is equal to minus dt. In our question, sec square x dx can be written as minus dt, and this part I have substituted as t. So we have minus of dt minus integral of dt upon d square. Later this can be written as t to the power minus 2 and then t to the power minus 2 plus 1 divided by minus 2 plus 1. We get I is equal to 1 upon t plus c. And after resubstituting the value of t, that is 1 minus 10x, we have our final result. Integral is equal to 1 upon 1 minus 10x plus c. Let's move to the next one. Number 6. Cos of root x upon root x. Okay, this is very simple. Let's take this root x as t. D upon dx of root x is equal to dt upon dx. Now derivative of root x is 1 upon 2 root x is equal to dt upon dx. So finally we got the value of dx upon root x s to dt. This 2 I will shift to the other hand. So in our question, dx upon root x, I can write 2 dt and cos of root t, cos of t. See, we come to till here and cos t, same this statement. Now integration of cos t is sin t, and don't forget to resubstitute the value of t, that is root of x. So final integral is equal to I is equal to 2 sine of root x plus c. Question number 27. Root of sine 2x dot cos 2x. Okay, I will take sine 2x as t. Derivative of sine 2x is 2 cos 2x. So I can eliminate this part. Let's see. Sine 2x is equal to 2. Derivative of sine 2x is equal to dt upon dx. Further, derivative of sine 2x is cos 2x dot derivative of 2x. What I did here, I did the derivative of trigonometric function and then algebraic function. So we get 2 times of cos 2x. I will send this 2 to the other hand. Cos 2x can be written as dt upon 2. Okay. Root of t can be written as t to the power 1 by 2. And then apply integral 1 by 2 plus 1 is 3 by 2 whole divided by 1 by 2 plus 1, that is 3 by 2. This 2 and 2 get cancelled. We have 1 upon 3 times of t to the power 3 by 2 plus c. Let's resubstitute the value of t. Integral is 1 upon 3 sine 2x to the power 3 by 2 plus c. 28. Cos x upon root of 1 plus sin x. Very simple. I am going to take 1 plus sin x as t. So derivative of 1 is 0. Let's do it. Let 1 plus sin x is equal to t. Okay. D upon dx of 1 plus sin x is equal to dt upon dx. This is 0 plus cos of x dx is equal to dt. Cos x dx can be replaced with dt. So we have dt upon root of t. We have dt upon root of t. Integration of 1 upon root 2 is 2 root. Integration of 1 upon root t is 2 root t. If you remember the yesterday's lecture, I just derived this value. Now resubstituting the value of t, that was 1 plus sin x. So final integral is equal to 2 times of under root 1 plus sin x plus c. Cot x dot log of sin x. Let's take log of sin x as t, because log x derivative of log x is 1 upon x And since it is logarithmic function and trigonometric function, first we will find the derivative of logarithmic function times derivative of trigonometric function. Let's see how. d upon dx of log sin x is equal to dt upon dx. Derivative of logarithmic function is 1 upon x. So 1 upon sin x times derivative of this other function, that is trigonometric function. Derivative of sin x is cos x. So cos x upon sin x dx is equal to dt. That means cot x dx can be written as dt. That means this cot x and dx over here is going to form dt, and this log of sin x is already t as per our substitution. So we have integral of t dt, and integral of t is equal to t square upon 2. So t square upon 2 plus c. I will be resubstituting the value of t, that is log of sin x. So final result is log sin x to the power 2 upon 2 plus c. Let's move to the next one. Sin x upon 1 plus cos x. Okay. Let's substitute 1 plus cos x as t. Since the derivative of 1 is 0 and cos x is minus sin x, just we will play with the minus sign to get sin x dx as t. 1 plus cos x is equal to dt upon dx. 0 minus sin x dx is equal to dt. So I will be taking this sign minus to the other hand side. So sin x dx is equal to minus dt. Meaning here we can write dt. So minus of 1 upon t dt. Again 1 upon x, integration of 1 upon x is log x. So this becomes log of t, and resubstituting the value of t, that is 1 plus cos x. So our final result is I is equal to minus log of 1 plus cos x plus c. So that is it for today. I hope you liked this video. If you did, then please subscribe to my YouTube channel. I will see you in the next one. Thank you very much.